Hello students, welcome to the lecture on expressions, statements, and arrays. And after the lecture we'll be able to learn the following objectives. Explain the concept of expressions and statements. Describe the local variable declaration statements. Understand the expression statements. Define the switch statement. Understand creating and accessing arrays. Discuss the initializations of arrays. Let's start with a brief introduction to expressions, statements, and arrays. Arrays are some of the most common data structures used by computer programmers. An array is defined as a series of data elements that can be uniquely identified by some number of indices. It is common practice to refer to an array as having a number of dimensions equal to the number of index items needed to locate a particular data element. A one-dimensional array, which is essentially a list, each data element can be located by referencing its position in the list. A two-dimensional array uses two indices to identify each data element, and can be visualized as a table with rows and columns. Now we will understand the concept of expressions and statements. An expression is a construct made up of variables, operators, and method invocations, which are constructed according to the syntax of the language that evaluates to a single value. Another difference between the source files of C++ and the source files of Java is that Java's source is written in Unicode, a 16-bit international character set standard. If one creates an ASCII source file, the Java compiler will treat the ASCII characters as if they were the equivalent Unicode characters. An example of expression is as shown. Statements. Statements are roughly equivalent to sentences in natural languages. A statement forms a complete unit of execution. Expressions can be made into statement by terminating the expression with a semicolon. A Java method body is a series of 0 or more statements. In the Java programming language, statements are the fundamental unit of execution. All statements except blocks are terminated by a semicolon. Blocks are denoted by open and close curly braces. Statements are executed for their effects. They do not have values. There are many different kinds of statements in Java. 1. Blocks. A block is a series of 0 or more statements between a matching set of open and close curly braces. The bodies of methods and switch statements are blocks. The bodies of if, for, while, and do while statements may also be blocks. Also, one can simply create a new block inside another block by enclosing code within curly braces. 2. Local variable declaration statements. Declaration statements establish a name, type, and possibly an initial value for a new local variable. Local variables in Java can be declared anywhere in a method. A local variable need not be initialized where it is declared, but it must be initialized before it is used. If it is not, the source file would not compile. For example, the snippet of code as seen here would not compile. This code would not compile because I is used before it is initialized. To fix this problem, one could initialize I when one declares it. 3. The empty statement. The semicolon is intended to be the entire text. If one was to explain the semicolon in a sentence, it would be, the empty statement, represented by a semicolon and nothing else, does nothing. The lone semicolon is an empty English statement about the empty Java statement. 4. Expression statements. Expression statements are valid Java expressions that are terminated by a semicolon. Unlike C and C++, not all kinds of valid expressions can be expression statements. In Java, there are 4 kinds of expression statements. Assignment expressions, such as A plus equals 5, B asterisk equals 7, or C equals 3. Prefix and postfix increment and decrement, such as plus A, minus B, C++, D minus minus. Method invocations, whether or not they return a value. Object creation expressions, such as new coffee cup. 5. Reachability. With one exception, statements in a Java program must be reachable. There must be at least one path of execution that will reach each statement. For example, the code on the screen would not compile because the ++I is unreachable. Let's now understand the control statements. Control statements are used in programming languages to cause the flow of control to advance and branch based on changes to the state of the program. The control statement is used to control the flow of execution of the program. This execution order depends on the supplied data values and the conditional logic. Java contains the three types of control statements. 1. Selection statements. Selection statements are used in a program to choose different paths of execution based upon the outcome of an expression or the state of a variable. If statement. This is a control statement to execute a single statement or a block of code when the given condition is true, and if it is false, then it skips if block and rest of the code of program is executed. This can be expressed as shown on the screen. If-else statement. The if-else statement is an extension of if statement that provides another option when if statement evaluates to false. Example, else block is executed if statement is false. This can be expressed as shown on the screen. Switch statement. This is an easier implementation to the if-else statements. The keyword switch is followed by an expression that should evaluate to byte, short, char, or int primitive data types only. In a switch block, there can be one or more labeled cases. The expression that creates labels for the case must be unique. The switch expression is matched with each case label. Look at the screen to understand the switch statement.
In this session, we are going to look at the Java control statements. We're going to look at the if-else switch, and in the loops, we'll be looking at the while, do-while, for loop, and break, continue, and return statements, and also finally we'll be looking at the labeled break and labeled continue statements. Coming to the if condition, the syntax of this if condition is something like this, where you will be having a conditional statement which will be evaluated to be a true or is going to be false. If the conditional statement is going to be true, then all the statements that are there inside the if condition are going to get executed. And if there is an else statement that is present, then the condition is going to be false, then all the statements inside the else block will get executed. So let us see this with an example here. In this main method, I have initialized the integer with x is equal to 4, and I have these if conditions checking if the value of x is greater than 5, and the next if condition, else if condition, is going to check for if value of x is greater than 3. And finally I have an else block which states that if both the x value is not greater than 5 or 3. So if I execute this straight away, it executes evaluates the second if condition stating that x is greater than 3. So I'm just going to run this example now. So it is evaluating to x is greater than 3. So this is an example of else if condition. Now let us look at the switch statement. With this switch statement, we can avoid a lot of nested if conditions. I can explain you with an example, something like this. Let us say we are asked to develop a program where when a user enters a number, by looking at the number, it has to print the month. So first let us see how the syntax is going to be. For the switch statement, the expression should evaluate to byte, short, or integer type, and the case will have the byte or short or int numbers out here. So whenever a number 5 is going to come, the switch statement always checks for the case 5 and starts executing all the statements inside that case. We'll directly see this with an example. So we can let us see this with here. I have a switch statement here, switch block. First, in this place, I'm getting the input from the user about the number to be entered, like enter the month number. And because the input is going to be coming as a string, I'm changing it to a primitive data type where I'm just passing with an integer.parseInt to and this will give me a primitive integer type, and I'm just telling it to switch to choose a block with this month number, and immediately it checks whatever the case is going to get matched. It will execute that particular case, and if nothing is going to get matched, then the default block is going to get executed. So I'll just run this example first. So it will ask to enter the month, and if I'm entering 2, it will print the month as February, and the shortest month of the year. So this is how the cases will get chosen based on the number that is coming to the switch statement. The advantage with the switch statement is that if your expression can get evaluated to an integer type or shorter byte, then you can avoid a lot of if and else if statements, so which will save a lot of processing to be done. Please remember that if you don't put a break at the end of each case, then there's a good chance that the next case will also get executed automatically. Say for example, I'm just removing the break or just commenting it here. Now if I start executing it, and if the case 1 is going to get evaluated, automatically the case will also get printed out here. So I'm just entering it 1 here. You can see that February will also get printed out here. So I have January, the case 1 is getting printed, and also the case 2 is also getting printed here. So by giving a break statement, you are avoiding the execution to fall to the next case also. And the other thing you have to remember is that the default block is always optional, and it need not be always at the end of the switch block. So now I'll just execute this program to touch the default statement. I'm just going to enter some other number which does not evaluate to any case, that is 23, and you can see that my default block is getting executed here.
2. Iterative statements. While loop statements. This is a looping or repeating statement. It executes a block of code or statements till the given condition are true. The expression must be evaluated to a Boolean value. It continues testing the condition and executes the block of code. When the expression results to false control comes out of loop. Look at the screen to understand the while loop statement. Do while loop statements. This is another looping statement that tests the given condition passed, so one can say that the do while looping statement is a past test loop statement. First, do block statements are executed, then the condition given in while statement is checked. So in this case, even the condition is false in the first attempt, do block of code is executed at least once. Look at the screen to understand the do while loop statement. For loop statements. This is also a loop statement that provides a compact way to iterate over a range of values. From a user point of view, this is reliable because it executes the statements within the block repeatedly till the specified condition is true. Look at the screen to understand the for loop. Branching statements. The break statement is a branching statement that contains 2 forms, labeled and unlabeled. The break statement is used for breaking the execution of a loop, while, do while, and for. It also terminates the switch statements. Shown here is the syntax of the branching statement. 3. Jump statements. Java supports 3 jump statements: break, continue, and return. These statements transfer control to another part of the program. The break statement. This statement is used to jump out of a loop. Break statement was previously used in switch case statements. On encountering a break statement within a loop, the execution continues with the next statement outside the loop. The remaining statements which are after the break and within the loop are skipped. Break statement can also be used with the label of a statement. Continue statement. This statement is only used within looping statements. When the continue statement is encountered, the next iteration starts. The remaining statements in the loop are skipped. The execution starts from the top of loop again. The program shown here shows the use of continue statement. The return statement. The last control statement is return. The return statement is used to explicitly return from a method. That is, it causes program control to transfer back to the caller of the method. The return statement immediately terminates the method in which it is executed. The program shown here shows the use of return statement. Let's now learn how to create and access arrays. An array is a container object that holds a fixed number of values in a single type. The length of an array is established when the array is created. After creation, its length is fixed. The program shown here, ArrayDemo, creates an array of integers, puts some values in the array, and prints each value to standard output. The output from this program is element at index 0 to 100, element at index 1 to 200, element at index 2 to 300, element at index 3 to 400, element at index 4 to 500, element at index 5 to 600, element at index 6 to 700, element at index 7 to 800, element at index 8 to 900, element at index 9 to 1000. Creation of arrays. One way to create an array is with the new operator. The statement as seen here allocates an array with enough memory for 10 integer elements and assigns the array to an array variable. If this statement is missing, then the compiler prints an error like, shown on the screen, and compilation fails. These few lines assign values to each element of the array. Each array element is accessed by its numerical index as shown on the screen.
In this tutorial, we will learn about creating, initializing and accessing an array. So in our previous example, we have created an array type variable to int type variable to store the record of 6 students. So we can simply, instead of writing in 6 different lines, we can initialize in just one line itself. So to initialize in one line, we need to first remove it and just use the two curly braces. First one is opening and another one is closing. So for example, if you want to store the marks of first student whose index is 0, since indexing begin from 0 in Java, so let's type the first student of the first student marks as 61 and another student marks as 56, student 3 marks as 89 and 12 3. So we have stored the marks of 5 students, which are 61, 56, 89, 12 and 3. So similarly, we can access the student marks as suppose we want to access the student marks 2, so we can write student 1 here, since indexing begins with 0. So 0 1 will access 56 here. So let's compile our code. Java C followed by an array example .java. Oh, I did a mistake. Now let's run our code, array example, and as you can see 56 printed. Now imagine if we want to iterate to all these elements and we want to print all of them, so we can do simply by using the for loop. So let's type, first remove this line, let's create a for loop, int index less than 5 index plus plus, and let's print all the marks here. So we're gonna write student and within the square bracket, we will write index. So as simple as that. Now what this for loop will gonna do, it will iterate through each elements which are present in this array. Since there are only 5 elements, so we had first pass the condition as less than 5. So it will first create an index variable, and it will initialize it with the value of 1, and it will gonna check for the uh, condition that whether index is less than 5 or not, and if yes, then it will increment the value of index. So let's recompile our code. Java C array example, and let's run our code. So we can, as we can see that 61, 56, 89, 12 and 3 got printed. So since we know that there are only 5 elements that are participating in this iteration process, so what if we didn't know the number of elements? So for example, if there are more than one element, or you can say that there are 20 or 30 elements, then if we want to print each of the element, then we can simply write the 5 instead of student dot length. Now dot length is a property in an array which will return the number of elements which are present in that element. Since there are only 5 elements, so it will compare it with 5 itself. So let's compile it our code and just check there is no change will be in the output. So as you can see, 61, 56, 89, 12 and 3 got printed here.
Now we will discuss about initializations of arrays. Although it is not possible to assign to all elements of an array at once using an assignment expression, it is possible to initialize some or all elements of an array when the array is defined. The syntax looks like as shown on the screen. The list of values enclosed in braces, separated by commas, provides the initial values for successive elements of the array. One-dimensional array. One-dimensional array is a list of variables of same type that are accessed by a common name. An individual variable in the array is called an array element. An array forms a way to handle groups of related data. Structure of one-dimensional array. Array indexes begin with 0. That means if one wants to access the first element of an array, use 0 as an index. To access third element, look at the example shown. Two-dimensional arrays. Two-dimensional arrays are used whenever the model data is best represented with rows and columns, or has two varying aspects. It is also the idea, although not the implementation, of graphics that specifies a 2- or 3-dimensional position with an x and y and z coordinates. Every data element in a standard two-dimensional array consists of the same type of object. Array elements are most often simple variables, such as floats or integers. In principle, however, any type of information can be stored in an array, so long as each item is the same. A two-dimensional array is a natural choice for storing any data that would naturally be placed into a table, and this data type is very often used to do precisely that. Visualizing two-dimensional arrays. Two-dimensional arrays are usually represented with a row-column spreadsheet style. Assume one has an array, A, with 2 rows and 4 columns. Two-dimensional arrays are usually visualized as a matrix with rows and columns. Use named constants for array sizes. It is useful to define constants for the number of rows and columns. The reason named constants can better code is that these numbers may represent part of the problem domain, and they will be used in other parts of the code. If a change is very necessary, changing one named constant will change all parts of the program. Each numeric constant should only appear once. Look at the screen for reference. Now in the end, let us summarize what we have learned in this lecture. Operators may be used in building expressions, which compute values. Expressions are the core components of statements. Statements may be grouped into blocks. The data type of the value returned by an expression depends on the elements used in the expression. The expression candence equals 0 returns an int, because the assignment operator returns a value of the same data type, as its left-hand operand, in this case, candens, is an int. The Java programming language allows one to construct compound expressions from various smaller expressions, as long as the data type required by one part of the expression matches the data type of the other. A Java method body is a series of 0 or more statements. In the Java programming language, statements are the fundamental unit of execution. All statements except blocks are terminated by a semicolon. Statements are executed for their effects. They do not have values. Java, as with most languages, supports multidimensional arrays, one-dimensional, two-dimensional, three-dimensional. In practice, most arrays are one-dimensional, and two-dimensional are also quite common.